All right, hi everyone. So we're talking about the remainder theorem today. We're closing out the last few sections of our unit, so I thought I could actually start real quick by talking about the calendar. So we're right here at the remainder theorem and finding zeros. We're actually going to start putting the last couple of days, especially yesterday, together and come back to this idea of factoring and factoring completely. And we're going to actually use synthetic division in order to factor a polynomial completely. Okay. On Monday, we're going to talk about solving polynomials. So we're actually just going to kind of bring it again all together and just talk about all the ways that you can solve, whether it be factoring, whether it be factoring by grouping, whether it be using synthetic division, but being able to solve a polynomial and find all of its solutions. Okay. On Tuesday, we'll do a short lesson and we'll just kind of bring everything together. I did want to make it a lesson instead of just give you guys a review, since it is the first unit and wanted to make sure we pull these units together. Wednesday and Thursday, you have a test review, which I'll pass out the test review on Tuesday, and then Friday, you take your first test. So hopefully, if you have time over the weekend and you have not already, it'd be a really good idea to look back at those quizzes and make sure that you're looking at those mistakes that you're making so that to start next week, you can focus on the test review instead of the quiz. But you want to make sure you're identifying those mistakes. Okay? I'm going to start by going over one synthetic division problem since we're going to need that today. That way, if you were gone or you just to kind of check in, we can kind of make sure we're all on the same page here. So I'm going to use a longer one. I'm going to use number 2. Okay, so when using synthetic division, there we go. Come on. All right, so when using synthetic division, we want to start by using the coefficients. So unlike long division, we don't need to actually write out all the terms. We can just use the coefficients. So if we're dividing by x plus 2, that means that x equals negative 2. So I want to write a negative 2. I'm going to put a box around it. And then I'm going to list out all my coefficients. So my first coefficient is a 2. Notice that there's no x to the third term, so I need a placeholder. So that's a 0. And then negative 6. And then 8, and then 2. Okay, I'm going to draw a line underneath here. And before I continue, I'm going to make sure this is okay. So this is x to the fourth, to the third, to the second, to the first, and my constant. So I know I'm good. Okay. The very first thing that we do is always bring down this first number. So this is a 2. And then I multiply my number inside with this number. So negative 2 times 2 makes this negative 4. I add these together, I get negative 4. And then I just keep repeating this process. So negative 2 times negative 4 is 8. Add them together, I get 2. Multiply, I get negative 4. Add, I get 4. Multiply, I get negative 8. And then add, and I get negative 6. So putting it all together, since I started with an x to the fourth term, synthetic division always knocks my original down by a single polynomial. So instead of this being a 2x to the fourth, it's a 2x to the third minus 4x squared plus 2x plus 4. So notice I have a 3, a 2, a 1, and a 0. And this right here is my remainder. So plus negative 6. And I'm going to divide by that divisor of x plus 2. So I get the exact same answer if I use long division, but obviously this is a lot a lot quicker, and probably a lot easier too. Okay, so let's talk about today's lesson. In today's lesson, we're going to apply the properties of synthetic division into factoring and also into just evaluating. So let's say that as this warm-up, it says to evaluate for f of negative 2. Remember that this looks like f of x, which means that it's telling you that x equals negative 2. So we're evaluating for x equals negative 2. So if I rewrite this, I'm going to say 3 times negative 2 to the third power plus 8 times negative 2 squared plus 5 times negative 2 and then minus 7. Okay? So without a calculator, negative 2 to the third power is negative 8. So this is 3 times negative 8. Negative 2 squared is 4. So this is plus 8 times 4. You probably don't have to do it in this many steps, but 5 times negative 2 is negative 10, and minus 7. Okay. I'm just going to kind of loop back over here. 3 times negative 8 is negative 24. 8 times 4 is 32. I'm going to combine these two. That's minus 17. Okay. Negative 24 plus 32 is, let's see, 6, 8. And 8 minus 17 equals negative 9. So this answer means that I would say that f of negative 2 equals negative 9. So meaning if I substitute a negative 2, my output is negative 9. Okay, now the point of all that is I can obviously do that and I can substitute and evaluate. Sometimes the numbers become a little bit bigger, and it's also just a bigger process that we can actually make a little bit easier. So let's say that we redo the warm-up. Oh, sorry. The remainder theorem up here says that if f of x is divided by x minus k, meaning if it's divided by something, x minus 2, x minus 8, then the remainder r is f of k equals r. Okay? All that's saying is that if I substitute something in, the answer is the remainder. Okay, so let me show you. It's this, number one says, let's redo the warm-up using this theorem. So using synthetic division, evaluate f of x equals, again, notice it's the exact same as up above, for f of x equals negative 2. So same thing. So again, this is saying that x equals negative 2. Okay, so if x equals negative 2, I'm going to put this here. Synthetic division, I use the coefficients. So this is a 3, an 8, a 5, and a negative 7. Notice this is x to the third, to the second, to the first, and my constant, so I'm good. I didn't miss anything. Okay, bring down the 3, multiply, add together, multiply, add together, multiply, add together. And notice that what I'm left with, this is always my remainder. My remainder is negative 9. So again, same thing we set up above. If I have f of negative 2, I get negative 9. So if my input is negative 2, my output is negative 9. All right? So can you substitute in and evaluate like you've always known how to do? Absolutely. However, synthetic division is a lot quicker method. By substituting in the remainder, that's what this is saying over here, right here. That's what that's saying. It's saying that my remainder is my answer. So if I substitute in, k is what I substitute in, r is my remainder. So just like f of x. Okay? So why don't you try number 2 on your own, and then you can check your answer. All right, so let's see. If x equals 5, I'm going to write a 5 here. Notice I'm not doing negative 5. It's telling me that x equals 5. So my coefficients are a 3, a negative 18, a 20, a negative 24. So that's the 4 to the third, to the second, to the first. And then I don't want to forget about my constant, which in this case is 0 since there isn't any. Okay, here's my line. All right, so follow the same steps. Bring down your 3. 5 times 3 is 15. Add them together. Multiply. Add them together. Multiply. Add them together. And then again, I don't want to stop right here. Notice I have a 0, because notice that my answer is going to be different. 5 times 1 is 5. Add together, I get 5. So if I didn't write this 0 in, I would have thought that 1 was my answer. But in fact, 5 is my answer. So if f of 5, then I get 5. So f of 5 equals 5, meaning if I substitute 5 into the equation, I can get 5 out as my answer. And notice that these numbers up here were really big. Without a calculator, that would have been pretty hard. Without a calculator, using synthetic division, it's pretty easy. Okay, so number 3 says, if the remainder of f of x squared plus k of x plus 34 divided by x minus 5 is negative 21, what is the value of k? All right, so there's a lot going on here. I'm trying to figure out what k is. So if I'm trying to figure out what k is, I need to know what x is so that I can solve for one unknown. So if this is saying divided by x minus 5, then this is telling me that x equals 5. If it's telling me that the remainder of this divided by this is 21, this is telling me that my remainder is negative 21. So what I can do is I can set up my equation, and I can say, so x is 5, so I'm going to say instead of x squared, I'm going to say 5 squared plus k times 5 plus 34 equals, and again, when I'm substituting that in, I'm going to get my remainder, which is negative 21. And notice that I've created an equation where I've substituted my x value, 5 and 5, into my equation, set it equal to my remainder, and now I have one unknown. Okay, so 5 squared is 25 plus 5k plus 34 equals negative 21. Add together my constants, I get 5k plus 59 equals negative 21. Subtract 59, I get negative 80. Divide by 5, I get that k equals negative 16. So what is the value of k? K is negative 16. Alright, try it again. Okay, now if you kind of get this, why don't you try number 4, pause it, see about your answer, or you can watch me if you're a little bit unsure. So again, if we're saying that we're going to take this and divide by x plus 3, then that means that x equals negative 3. And if we're saying that this is negative 19, then that means that this is saying my remainder is negative 19. Okay? So I can substitute in. I know my x and I know what this is equal to. So I have negative 3 squared plus k times x, which is negative 3, minus 10, which gives me my answer, or my remainder, of negative 19. Okay? So negative 3 squared is 9, and I'm actually going to add these two things together. So negative 3 squared is 9. 9 minus 10 is negative 1. So I get negative 1 minus 3k equals negative 19. And you guys should be doing this without a calculator. Add 1 to both sides. Add 1, I get negative 18. Divide both sides by negative 3. And I get that k is 6. Alright, pretty cool. Alright. Now, besides using synthetic division to substitute, and besides using synthetic division to solve for that unknown value of k, I can also factor completely. So this is saying the factor theorem. It says if f of x is divided by x minus k, which again, like x minus 3, x plus 5, something like that. And when you divide, you get that remainder of 0. So that's what this is saying. If you do this and you get that this equals 0, meaning there is no remainder, then this is a factor of f of x. And that's what we talked about the other day when we were doing long division, and we kept saying, hey, look, we're getting a remainder of 0. That means that this is the divisor is a factor, and it means that that's where it would hit on the x-axis. Okay? So that's what this is trying to say. So write this down. Okay, so what that's saying is if you get a remainder of 0, sorry, that should say n, then, oh, sorry, nope, I meant though. So if you have a remainder of 0, the divisor is a factor, meaning it is a solution. Okay, so let's apply that. Number 5 says to factor f of x completely. Completely means I need to be able to factor it totally, so that if I were to multiply it back out, I get back to this original. So if they're telling me that x equals negative 3, that means I already know that one of my factors down here is x plus 3. So I can start with that. Well, if that's one of my factors, I can use synthetic division to take this x to the third and knock it down to an x squared. And if it's x squared, I can now factor it because it's quadratic and it's smaller. It's easier. Okay, so I have negative 3 here. I have a 2, an 11, an 18, and a 9. Bring down the 2, multiply, add them up, multiply, add them up, multiply, and notice what I get as an answer. I get 0 as a remainder. If I didn't get 0, I would have done something wrong because it's telling me to factor this given that x equals negative 3. So it's telling me it's a solution. And the point of this was because if it's a remainder of 0, look what I'm left with. If I started with x to the third, I'm going to write it actually over here. If I started with x to the third, then that 2 is 2x squared plus 5x plus 3 with a remainder of 0. Or equals 0 since that equals my remainder. Now I can factor this to finish solving. So this has to be a 2x and an x equals 0. I actually want this to be a 3 and this to be a 1, so that's plus and plus. Okay, and then, sorry, we actually don't want this 0 here since I'm just factoring, I'm not solving. Okay, so notice I added 2 more factors, and I'm going to add these here and say 2x plus 3 and x plus 1. Okay, and then that, if I multiplied it all out, would get me back to this because I have an x times a 2x times an x, which is a 2x cubed. So we just don't want to forget this one that we were given. Okay, let's flip to the next page. See how we're doing on time. 17, okay. All right. Alright, I'm going to do this next one with you, obviously, but if you want to pause it, feel free to pause it, and you can do it by yourself. But same idea here. Again, we're factoring completely. Okay? So if we're factoring completely and we're given one of the factors, that means that we can use synthetic division because we know that negative 2 is one of our solutions. And if we know that it's a solution, we can make this go from an x cubed all the way down to an x squared. So down 1. Okay? So my first coefficient is a 2, and then a negative 1, and then a negative 13, and then a negative 6. I want to make sure I didn't miss anything. To the third, to the second, to the first, constant. Good. Okay, bring down, multiply, add, multiply, add, multiply, and again, notice that we get that remainder of 0. If we didn't get the remainder of 0, something is wrong because it's telling us it is a factor. Okay? So what's left, because I started with an x cubed, this is a 2x squared minus 5x minus 3 equals 0. Sorry, I keep writing equals 0. Don't write equals 0, we're not solving. Come on. Okay. So if I factor this, I get 2x and x. I want to put a 3 here and a 1 here. 2 times 3 gives me negative 6, plus 1 is negative 5. So when I come down here and I write my factors, and again, remember, order does not matter. 2x plus 1 times x minus 3. Okay, I wrote this here, and I want to stop here because, remember, this, if I multiply this out, 2x times x gives me 2x squared. But I needed to get back to my original, which was 2x cubed, which means I need to remember this factor right there. So I used it, but it's still part of my problem. Now it's factored completely. Everything's simplified. It gets me back to my original. Okay? Alright, at this point, you should be able to do the next one. See if you can do this problem, and then unpause it, and you can just jump to the answer to check it. Okay. So notice that this factor is written a little bit differently. I'm going to write it over here. If you were to solve that, you would have to add 1 and divide by 4. So 1/4 is what I'm going to put over here, my little box. My coefficients, I have a 3, a 2, a 1, and a constant, so I have all of them. I have an 8, I have a 10, I have a negative 83, and I have a 20. Again, we should be doing this without a calculator. Okay, so I have an 8. A fourth of 8 is 2. Whenever we're looking for a fourth, it means we're dividing it by 4. Add these up, I get 12. A fourth of 12, or 12 divided by 4, is 3. Add these up, you get negative 80. Negative 80 divided by 4 is negative 20. And again, notice that I get this 0. If I didn't, I did something wrong because it's a factor. It must give me a remainder of 0. Okay? So I started with 8x cubed. I then get down to 8x squared plus 12x minus 80. Notice that I can divide all of these by GCF. I can divide all of them by 4, which leaves me with 2x squared plus 3x minus 20. Okay, I factor this. I get a 2x. I get an x. If you haven't gotten this far, try to factor it by yourself. Alright, let's see. Put a 10 here. Can't put a 10 here. 5 and 4. If it's 5 and 4, then this would have to be the 4, and this would have to be the 5. Let's see if that works. It does. 2 times 4 is 8, so that has to be a positive 8. Take away 5, leaves you with 3. Okay? So, when I write this out, factored completely, it doesn't matter the order. I'm going to write, you do have to write this 4 as your first, so don't forget your GCF. So it's 4 times 2x minus 5 times x plus 4, and then don't forget the original factor that you were given, which was 4x minus 1. Okay, and it might be smart to go back and check your work. Notice that if I did a 2x times x, I'd get 2x squared, times another 4x gets me to 8x cubed, which is what my leading term was. So that helps me kind of check to make sure that my answer gets me back to my original. Okay. Alright, let's try one last problem. It's kind of a bigger problem. In this problem, you're given 2 solutions, which means we can use synthetic division twice. And we're going to write it in factored form, identify the zeros, and draw a sketch. So now we're bringing in even more. Okay, so I'm going to use synthetic division twice in this one since I have 2 answers, which means I'm going to go from an x to the 4th all the way down to an x squared. Alright, it does not matter which one you use first. I'm just going to use the 4 first since that's the first one that's written. So, here's my 4. My first coefficient is 1, 1, negative 13, negative 25, and negative 12. Alright. Okay, if you want to try this on your own, that would be awesome. Otherwise, maybe watch me get to the second factor, and then you can try it on your own. Okay. Bring down your 1, 4, 5. Remember, you must get 0 at the end, so that's the great part about this. It's easy to check your work. Notice I get 0. Alright, so now what I'm going to do is I'm going to say, okay, well, now my new coefficients are 1, 5, 7, and 3, but I'm going to now use my other factor, which is negative 1, and I'm going to put it right here, so that way I don't have to rewrite all this. And then I'm going to draw my line, and basically I'm going to forget all of this up here. Bring down my 1, multiply, add. And notice that right here I get 0, and that's where I'm stopping, since up here that was my remainder of 0 and it didn't matter. Okay, if it's too confusing to double stack it like that, you can always just rewrite it twice. Okay, and now again, notice that I started with an x to the 4th up here, which I know is even and is positive coefficient, so it's going to look like a quadratic, but, you know, kind of like this. Okay, so I'm going to rewrite my function, 1x squared, or just x squared, plus 4x plus 3, and I am going to write equals 0 here because I actually do want to solve, since I'm trying to find the zeros. I'm going to stop. Okay, so I factor this. It's a fairly easy one to factor. I have a 3 and I have a 1, plus and plus. So x equals negative 1, x equals negative 3, and I don't want to forget about the factors that I had up above. I used x equals 4, and I used x equals negative 1. So I was given 2 of my 4 zeros, and because of that, I was able to use synthetic division to find my other 2. Okay, so my zeros are negative 1, 0, negative 3, 0, 4, 0, and notice I get to this last one and I realize that I was about to write negative 1 again. I don't need to, and I shouldn't ever write them twice, but I am going to go back and I'm going to draw a line underneath this, or just box it. I'm going to box it because that means that that is a double, or it's going to bounce, so it's twice, so I need to make sure that I include that in my sketch. Okay, now this function down here is asking me to write it out factored completely, so I'm going to go back to the beginning, and I'm going to actually write my first 2. It doesn't matter the order. If I have a 4, then that means that I would write that as x minus 4. My other one that I was given was negative 1, so that means x plus 1. And notice I found that solution again, and that happened twice. So you can either write x plus 1 and x plus 1 twice, or you can write x plus 1 squared, but you have to write it twice to show that it did happen twice. Okay, and then my other one is x plus 3. So notice that I have x minus 4 hits this one, x plus 3 hits this one, and the x plus 1 squared hits both of these. Okay, and again, you don't have to write squared, you could just write x plus 1 times x plus 1, but you can't write it once. Okay, again, because x squared times x is x cubed times this x over here, so if I multiply all of them together, I get back to x to the 4th, which was my original problem. Okay, so my sketch is going to look like this. Alright, I'm hitting at, let's see, I'm hitting at 4, 0. You guys might want to try to graph this. This is a good place to pause and try it on your own first. Hitting at negative 3, and then I'm hitting at negative 1, and I'm going to circle it because I'm hitting there twice. Okay, I know that this is even, and I know that it should open up, so if I look back at, this is what it should look like, something like this. Okay, but I know both end behaviors should be going up, and I know I need to bounce, oh my goodness, I know I need to bounce off of that point that I circled. What is going on? Okay. Oh my goodness, what the heck? Alright, so I start up here. Instead of going through the point, I hit bounce back off, and then go through this point right there. Try to actually go through it. Arrows on both ends. So it's an even function, and behavior both goes up. Have my bounce, so I have 2 solutions, 2 solutions, 3, and 4 solutions. Okay, and then again, I just want to highlight that this right here would give me x squared, and this over here would give me x, and this over here would give me x, So if I multiply all four of the, or all three of these together, I get x times x squared times x, which gives me that x to the fourth, which was what my leading term was raised to. So I know that this is right. If I forgot about that squared, I would just have an x to the third. Okay? So your homework, just like always, is going to look a lot like the same. I just want to highlight a couple things. So you're going to divide these as long as you know that uh, hold on. Okay, sorry about that. Notice that number 1 and number 2 both say divide. You cannot use synthetic division. Okay? It does not say that these are factors, that this is a factor, that this is a factor. So you cannot assume that it equals 0 and then solve. Otherwise, you're assuming that's an answer, and you can't assume that. So since it doesn't tell you that it's a factor, and it just says divide, unfortunately, you have to use long division. So you're going to have to do that for both. Okay? In number 3 and 4, you're going to factor completely. You're going to be given a factor, which is awesome. Then use synthetic division. In 5 and 6, same thing, factor completely, and you're given a factor. You're told it's a factor, so use it to do synthetic division, and then finish factoring, and just make sure that in your answer you factor completely. Okay. In numbers 7 and 8, use synthetic substitution. Okay, don't do this the long way and substitute, and use synthetic substitution. So use what we did in the notes. Number 8 looks like the two problems we did on the front side of our notes, so if you need to, look back at it. And then number 9, number 10, and number 11 are all asking the same thing. Okay, given a solution, so this is telling you that x is 10, so use synthetic division. You can knock this down a degree, and then you can factor what's left. You can identify the zeros and write it in factored form, and then you can draw a sketch. So it is asking you to do a lot, but we're at the end of the unit. We should be able to pull everything together. Okay? Make sure you check your answers. Make sure you guys grade your homework. I'll be back on Monday morning. It's I think our first late arrival. But if you have questions, feel free to come in, like maybe 8:50-ish or something like that, or, even 9 o'clock, and we can go over any questions that you have. Okay? All right. Have a good weekend.